on this computer. Already. You can start. So welcome everyone to the CLEA seminar, next one, and apologies for the delay today. Our guest Alvaro Moreno will be presenting his research on the minimal agency, natural and artificial. Welcome, Alvaro.
Thank you for the invitation. It's a pleasure to be here, and sorry for the delay. Then I have now a problem.
No, I can switch.
You have to.
So you have
okay, okay. Then I will indicate you when the next one. So sorry again for this data. So the content of my talk is divided in implicitly in four parts. An introduction of the concept of agency. Then this introduction will include some explanation of the requirements that the concept involves, in my opinion. Then addressing the idea of minimal agency, what is meant by minimal agency in different domains, and also a short review of different proposals, really what I would call radical proposals. And then some criticism about that, and in my view, the limitation of these proposals and what is lacking in these proposals. And then finally, I will address some paradoxes or puzzles that the idea of minimal agency, as is usually understood, implies. And then the conclusions. Next, please.
What is it?
No, next, please.
You don't see it?
No.
Oh.
Sorry. So, by the concept of agency, there are very different domains in which the idea of agency is addressed. So, and that gets different approaches and very different views. So there are approaches like human sciences, robotics, philosophy, biology, cognitive science, etc. And all these different science have, in many occasions, different views of what is meant by agency. Broadly speaking, very broadly speaking, an agent is a system that has the capacity to perform some action in the environment. Now, by that, we can understand different questions. For example, a robot usually does some action in the environment, but also we can understand the robot as an extension of a human being. And then the question we can ask ourselves is whether the agent is the robot or the human being that has built the robot. So that's why I will address the concept of agent in the sense of autonomous agent, because otherwise we can have an infinite regress considering that what is an agent, in fact, is not a true agent because it's a tool of another agent. Okay. So here we can have just a review of different approaches. But the interesting point is what these approaches has in common. And I have put in red which are the ideas that all of them in some some basic sense share. So this is the idea that there is an interaction in the environment. This interaction is not an instantaneous interaction, but has to perform during some times in a certain way, that the interaction, the process of interaction are in some sense normative or have a purpose or achieve a goal. And also that the agent is the source or the cause of these actions. Okay, so basically here we have two ideas. That the idea of agent, which is the causal source, the self of a set of actions. And this implies, I will come back to this point, that implicitly the agent has some form of individuality, but we will deal with that later. And the other aspect is the action, which is purposeful or goal-oriented. Now, these two features or these two aspects require, on the one hand, a specific set of material relations that define the system from the rest of the world. This is what the agent is. And this set of material relations or organization is what I would call the constitutive dimension of agency. That is the subject of the actions. And on the other hand, this constitutive dimension or organization is what yields or produces constraints modifying the external environment. And this is the interactive dimension of the agent. That is called the action of the agent. Now, the actions of the agents are normative. This means that this action could fail. So that is what is meant by a norm, that these actions should be in some way, and that we can say that if this way is not achieved in the proper manner, this action is failed. For example, my action is intended to catch this, but if I don't catch properly, my action is failed. So that's why the example of is a norm. The action of an organism is, for example, avoiding a prey, but this could fail, or get food, but this could be successful or could fail. Now, the norm is endogenous of the agent. What is meant? That if the norm is alien, so then we should find for the grounding of this norm, for the origin of this norm, and then we can enter in an infinite recurrence. That's why the idea of autonomous agency means that the agent should provide themselves their normativity. And I will address this question. How can we naturalize this concept of normative actions? If the agent should do certain specific interaction, because if the agent did not fulfill this interaction, sooner or later, it will be disaggregated, it will be disintegrated. So the sense is that the agent is a precarious entity. The agent should do some process in the environment in order to stay there, to maintain its identity. And this is the core of the idea of normativity in a naturalistic sense. And that's why also that an agent is the cause of the actions, but at the same time is the consequence of the actions, because the actions finally are what maintain the agent. So if the agent doesn't perform according to each the identity of each agent some specific actions that maintain this far from equilibrium, precarious identity, we, for example, Aristotle said, we are rational beings. But if we don't act as rational beings, if we don't perform such and such type of things, if we behave as animals, our identity, precarious identity as rational agents will be finally destroyed, will be not maintained, is maintained through these actions. And so for an unicellular organism, if the unicellular organism doesn't look for food in a proper way or doesn't avoid the prey in a proper way, it will be disintegrated sooner than later. Now, this is an important question because it enters the question of the time. If we say that the agent is maintaining through its actions, but at the same time, it is the source of the actions, this requires to explain the concept in two time spans, different time spans. So the first time span is the constitutive dimension of the agent. So the agent, in order to do things, should be constituted precariously, but should be constituted, because otherwise it cannot trigger actions. For example, the cell should be constituted as a cell through metabolism, etc., in order to move. But then the movement, if successful, will, in a larger time scale, will allow that it gets food and then is maintained. But there are two different time scales. Okay. This relationship between the constitutive domain and the interactive domain is what I will close the constitutive interactive closure principle. So this is shown through a picture here. The agent is precarious and thus actions in the environment. These actions return affecting the constitutive process of the agent. And again, the constitutive process permits the agent to do actions in the environment and so on. So through the actions, the agent self-constitutes, self-maintained. Now, then the conception of an autonomous agent is thus considered as a set of processes generated by a system as an integrated whole, which is the causal source of these processes, performing according to a certain goal or norm, contribute to the maintenance of the agent, and functionally modifying the environment. And this is the summarizing what I have said. The point that I have mentioned here is an integrated whole. And this is something which is a very important aspect that many philosophers consider as essential for defining what is an agent. So, for example, when considering a human being, the digestion of a human being, or some very local movement of the human being performed by a part of the organism, not taken as a whole, is not usually considered as an action. As an action is when the whole agent is involved. If I can avoid, okay. Once we have examined what are the core characteristics of agency, let us address the idea of minimal agent. By that, is very simple. At first glance, the simplest form, either natural or artificially built, of a system that fulfills the mentioned characteristic. Now, this could be, next please. Oh, but I can't. There are, sorry. There are different views or different points of addressing the idea of minimal agency. One is synthetic biology and artificial life, or there is computer science, or there is robotics, or biology, or cognitive science. Now, basically, there are two ways to address the question. One is by the more radical is try to build, starting from scratch, from purely physical or chemical systems or pieces, and through these material building blocks, build a system that would be able to perform agency. Others prefer to address this question looking for the simplest real empirical objects that show these properties. And this implies two different conceptions. One is to conceive the idea of minimal agency in the sense of what is the simplest system, the simplest agent, as it should be. And the other one is the simplest in the phenomenological domain, the simplest system, the simplest agent as we know it. What does it mean? It means that in the second case, we are looking for the extant systems and try to say which one is the simplest. The other perspective is to say, Papa, this is a contingent fact. Maybe we can we can build in a laboratory or in another planet or in whatever dimension, thank you, a different type of system which could be simpler, and then by definition, minimal agent should be addressed from this perspective, which is the simplest as it should be, as it could be, not as we know it. But we will see at the end that this also raises some paradoxes and some difficulties. I will address now 4 different radical proposals. I say radical because they are really minimalist. By the way, for many philosophers, because the tradition in philosophy is to start with human agency, for many philosophers, the simplest form of agents are at maximum some animals, or at least some unicellular eukaryotic, some protist organisms. Here I will analyze 4 proposals that are much more simple. One is the so-called self-propelled droplets that authors like Ikegami or Hanchik have developed models in this. They basically consist of a combination of chemical reactions and self-assembly processes and convective phenomena that together trigger a spontaneous global movement in an oily system in an aquatic environment. This movement does not depend on getting nutrients, so no matter nor energy from the environment. So in that sense, it's not a dissipative process. They just consume their internal oleic anhydride that is available. For example, for Ikegami, some of these systems are considered just as steps in the way of constructing self-organizing molecular system capable to achieve synthetic molecular machines or nanorobots. But for others, they hold and they maintain that there are already minimal agents. Here we can see two examples. So next step in this direction, from the simple to more complex, are the so-called molecular machines, or sometimes molecular robots. Some of them are artificial, but others are existing in cells or natural. What is a molecular robot? Basically, it's an artificially built molecular device which is capable to perform a variety of tasks. For example, they move, transport, molecular cargos, they build other molecules, or sometimes they act as a pump, or a rotor. So they perform many different tasks in the cells, or in pharmacy, or for other medical purposes, or even could be used in different senses, industrial for building very teeny computers or other machines. So actually much more complex and are capable to perform in very interesting tasks. For example, there are a robotic ribosome that assembles peptides, a four-wheeled molecule that moves on a metal surface, or a molecular propeller that pumps water in the hydrophobic surface. Here we have some examples. And also, sorry, before addressing the next example, in the natural world, we have many molecular machines that move in microtubules, or in prokaryotic cells, ATPase molecules that pump ions or act as rotors. Then the other example, the third examples, are the case of Virules or prions. These, unlike synthetic molecular robots, these entities are the result of a natural, not designed process. In many sense, they are similar than molecular machines, but in other sense, they are different. They are different in the sense that they can deploy independent of the cell actions, and they are capable of self-assembling, self-replicating, or even autonomously evolve. The case of Virules is different in the sense that they could include small displacement. They are capable to evolve in an interesting manner. They act in some aspects as the way we describe machines. They, when we say they are ratcheting or lever, spring, etc. Prions, I don't know how it's pronounced, act as templates. There are proteins, just composite devices like virus, which are composed of proteins and nucleic acids, but prions are just proteins, but act as a template which guides the unfolding of more proteins. So in some senses, is similar as what the virus does. Prions are pathogens. Viruses are not always pathogens. They also perform other tasks that are not at all pathogens. Here we can see how viruses are structured and how these are attached to the surface of a cell, and then they act as a spring, introducing inside the cell the nucleic acid, RNA or DNA, and they then the machinery of the cell is hijacked, so to speak, and in fact replicates the virus genetic information, and the cell is usually destroyed and then infect other cells. The fourth example is what I would call autopoetic protocells. Let's first clarify the concept of a protocell. A protocell is any artificial, either material or computational or natural systems that involves two aspects, a compartment and a set of chemical reactions inside the compartment. If I say that I use the adjective autopoetic protocell, then I add a requirement that there is a complementarity between the compartment, in the sense that the compartment is fabricated by the reactions that happens inside of the compartment. So, and at the same time, the compartment is a necessary condition, for example, ensuring the proportion, the proximity of the components, so as to maintain the reactions, and the reactions produce the components. So it's a causal loop, and this is the idea of autopoietic protocell. And this is usually also understood as a proto-metabolic system. This is, of course, much simpler than any present-day prokaryotic cell. Now, here there is an example. This is a computer model provided by Ruiz Mirazo and Mabelli in 2007 and 2008. And this model is interesting in the following sense. The reactions inside not only produce the lipid components that self-assemble and form the compartment that maintains the reactions working inside, but also the membrane, the compartment is selectively permeable. Why? Because some of the components produced in the network are some short peptides insert in the membrane, and when the osmotic pressure is becoming higher, these channels open and then expel ions, so that the osmotic pressure avoids that the cell bursts, the cell explodes. In that sense, this is an exchange of material, an active exchange of material inside and outside, and the authors said or proposed that this is a case of minimal agent, in the sense that the system is autonomously doing things in the environment. which kind of things? Ions, expelling ions. And this action is supposed to be functional in the sense that this action happens when the system needs to do that in order to avoid explosion. Here is more detailed explanation of the model. Now, very shortly, I will say some problems that these different models, the different proposals present. As for the droplets, the self-propelled droplets, the question is that they move, but this movement has not any function. The movement does not affect in any sense to the identity of the droplet. So this does not fulfill the conditions that we have set for defining a system as an agent. Nanorobots. Nanorobots are more complex, but they are not autonomous. In what sense they are not autonomous? They depend on externally imposed norms. In the case of being artificial, this is different the case in natural nanorobots, nanomachines, because natural nanomachines, those that are ATPase, for example, perform actions that are functional for the cell. And since they are functional for the cell, ultimately, the cell also permits to build this system. So ultimately, there is a kind of causal loop that in some sense, these molecular machines contribute to their own maintenance. However, the question is that one may wonder whether these systems are really autonomous in the sense that they are not self-capable to build themselves. We will come back to this question, which is not very clear. As for virus or prions, they do not possess a constitutive organization complex enough to perform agential capacities. So, in some sense, these capacities depend on the fact that they infect a cell, which is much more complex than virus or prions. So they are not organized to do these things by themselves. They need a much more complex organization. But again, we will come back to this question. So, lastly, what about protocells, either natural or synthetic? They are capable to build themselves and maintain themselves, and they have some individuality. But are they capable to perform a functional modification of the environment? Well, not exactly. They are able to modify their own internal constitution, but they are not changing the environment. By pumping ions, they don't change the pH whatsoever of the environment. The environment is the same. They change themselves. And this is not an action. This is just a form of adaptivity, just in case. So what is lacking? And I will put here in red the two questions that, in my view, are lacking. Minimal agency requires adaptive regulation, and minimal agency requires a minimal sensory-motor subsystem. I will try to explain briefly what's that. Basically, the idea is that since the internal organization of an agent should be maintained, it requires the production and continuous renewal of constraints harnessing the flows of matter and energy, so to keep going. Sorry, this is the two conditions that have been fulfilled. So I will go, for lack of time, to the 3 and 4.
This screen is
Up. This is the third condition. Minimal action requires adaptive capacity. Why? Because if the action, in order to be functional, the agent must compare different possibilities and determine which one will lead to a better or less bad fulfillment of the boundary of viability. Let's clarify this point. If the system has not any way to detect that something is getting wrong, but without immediately implying it's dead. So if the system were blind, just is self-maintaining or just is destroyed, then it would be do nothing in order to improve or avoid such situation. Now, that's why the system has to detect that something is getting bad in order to trigger some action. For example, the system detects that its metabolic condition is getting bad, and then something has to be done. For example, getting sugar. And that means that if in the environment there is sugar or there is food, instead, or in some place in the environment there is food and in another place there is not. So if there is a possibility to do something in order to avoid destruction, then the system evaluates and triggers this action. And this means a form of anticipation. So far, this implies the capacity to evaluate sequentially temporal situations and determine which possibility is functional at each moment in time. This requirement follows from the necessity that action in the environment becomes useful for the agent. So organizationally, this requires a subsystem that operates in a relatively autonomous way from the basic constitutive process. And this also requires a kind of system that detects things in the environment, things that are good or bad for the systems, and also a device that permits the system to move or secrete chemicals or do actions, in fact. And that these two detections, action devices would be coordinated. For example, in motility, the viability of the sensorimotor loop is strongly affected by size-time constraints. And these constraints, these times, is independent of the metabolic constitutive dynamics. I will show a picture taken from a paper written by Egbert and Di Paolo in 2009, in which they provide a computer model showing that there are two different cycles. The autopoetic cycle, so the constitutive cycle, which is the first one, and then other, which is properly the sensorimotor loop.
Are we having the correct picture?
Yes.
Yeah.
Okay. In sum, minimal action requires a self-maintaining individuated organization This is what we have explained in the case of the protocells, but capable of, first, preventively triggering specific constrained processes, actions in the environment, according to detected environmental conditions, so as to modify these conditions for the system benefit before the system reaches the viability limit. In other words, this is what is called adaptive regulation of sensorimotor interactions. Adaptive regulation could be either modifying internal conditions, this is not action, or modifying external conditions, and this is agency. I will here, just before addressing the last part of the talk, clarify a point. I have said constrained processes. That's important to clarify. An action is not necessarily something that is a direct process. Imagine that a bird is surfing there, just moving very smoothly in the streams of air, just like a surfer in the water. And he can changes directing action just by harnessing the forces of the way of the streams of the air, of the flows of the air, not necessarily providing the force, just by constraining or harnessing the movement, the alien movement, but these constraints are provided, the source of is the agent, and are purposeful. So, finally, puzzles and paradoxes. Now, when we consider the concept of minimal agent from the perspective of the natural world, we face some paradoxical cases. I will give you some examples that we have already mentioned. Viruses, prions, plasmids, these systems seem to behave as truly autonomous agents despite their extreme simplicity. In what sense? In fact, they perform functional actions, and these functional actions are not functional for the system they infect. They are functional for the system, for the virus, or for the prions. And, and they evolve. So, of course, they are not capable to do the things that characterize agency without the more complex organization of the cell that they infect. But in some sense, they do things by their own behalf, for themselves. That's why they are paradoxical. And that's the question. Are these systems an example of minimal agents? Or suppose a different example. A system in which we have protocells, which are not agents, but they modify the environment in a long term, because they exchange, they have some proto-metabolic processes that during many generations, through a very long period of time, and because there is a whole population, modify chemically the environment, and suppose that this modification allows a kind of ecological or niche construction that is functional, in the sense that it favors the following generations of these protocells. So in some sense, there is an active regulation. If we look at a very more collective and long-term perspective. If we look at a short-term individual perspective, hardly can we consider each of these protocell an agent. But what about the whole population during many generations? Are these systems, in fact, are these systems, in fact, minimal agents? If we think of what is happening in the natural world, we see that the evolution of agency, the origin of agency, implies historicity, implies collective processes, implies nested organization, and implies entanglement of spatial and different temporal scales. And by providing a complex framework like that, full of different types of evolving agents, some more complex, some parasites, etc., a domain of minimal semi-autonomous system necessarily appear. They are minimal because they use the much more complex organization of their hosts. Yet they are semi-autonomous because they act purposefully on their own behalf. Coming back to what we have already said, that the concept of minimal agency can be understood in two different senses, as it should be and as we know it. In the first view is much more radical. And then the question is, we can probably fabricate a minimal system that will instantiate agency without all this mess of entities. But the second perspective reveals some interesting points. Because actually, one may think that we are interested in minimal agency. Then, if we are interested in minimal agency, why care about the history of life? This is pointless because we are only interested in how agency the history of life shows the contingent fact of how agency in our planet has become more complex and diverse, but we can probably produce things different way in a laboratory. Yet, biological evolution shows intricate processes of agency minimization and with a host of other borderline cases. And the question is this a contingent fact? Or could we really create artificial minimal agents without such mess of interactions? And I leave this as an open question. Thank you for your attention.
Thank you. So we have a lot of time for discussion, questions, comments. Maybe I'll unshare the slides so that we can see.
I have to open the.
You can see that. So, who would like to comment or ask questions? Francis.
Yep.
Traditional.
Well, you start your conception of minimal agency by first assuming it as a self-maintaining system and then assuming that the system has a sensory-motor interaction, meaning that it has what I call condition action rules. So it senses conditions and it responds to a condition by an action. But my approach is to try to understand the emergence of the minimal agents by assuming that the condition action rules are there first, because a condition action rule in an agent is goal directed. The action is there in order to make the agent get to its goal. But what you could imagine is that in nature, physical, chemical processes, they can be seen as condition action rules. namely a chemical reaction, the way we are using now, is a condition, namely some molecules come together, and action, some new molecules are produced. So you can start by assuming that the world is full of condition action rules, which are embodied in all kind of molecules and physical conditions and whatever. And if those are brought together in such a way that the net effect is that they always go back to the same configuration, then you get something self-maintaining, and then you get a minimal agent made from the conditional action rules. So instead of saying you first have the agent and then you have the condition action rule or the sensory motor regulation, you can start assuming there are condition action rules which are not yet goal directed. But if they come together in the right way, you will get something that becomes self-maintaining. And then by the fact that it is self-maintaining, natural selection will maintain it. And so it will continue to exist, it will survive.
Maybe I have not well understood. Self-maintaining, of course, implies exchange of matter and energy with environment. And I imagine that that supposes an idea of individuation, right?
Yes.
So self-maintaining implies a structure of relationship between reactions and self-assemblies, autocatalytic reaction, etc., that are structured together in order to maintain a system as a whole with an identity and a border, right?
Well,
a limit.
Yeah, okay. I mean, at the moment in our models, we're not yet speaking about the border, the topological boundary, but we're speaking about a system of reactions that is autopoetic in the sense of it is self-maintaining, that it's whatever is consumed is produced again. And of course, for thermodynamical reasons, there must be the equivalent of food entering the system. But within this network of reactions, you can have something that's self-maintaining.
For example, concentrations is necessary to ensure the concentrations. It's necessary to ensure a selective control of what belongs to the system and what doesn't belong.
You do not necessarily need to assume that there is a control of what belongs to the system or not. You can show.
I'm not saying that at a topological border. I just speak in the term of a conceptual border.
Yeah, there is a closure. There is a kind of an organizational closure in the sense that at a certain moment you will have a network of molecules producing other molecules where everything in there remains.
Because if you
added, nothing old is disappearing.
Okay, because if you speak in terms of self-maintaining, there is a self.
Yeah.
The self necessarily should clarify what is not the self, say the environment and the system, right?
Yeah.
So this implies some kind of at least conceptual border.
Yeah.
Conceptual limit of what is the system and what is not the system.
Yeah.
Now, then in order to try to answer, I have also to ask you for another clarification. This system displays some processes or actions or not?
Yes.
How do you define these actions? Are these actions have to be normative or not? Because most of the authors say one thing that defines an action from a merely inner action is that an action of an agent is normative, should fail or can fail. Or
it is normative in the sense that the implicit goal is self-maintenance. If it fails, the system does not maintain and it falls apart.
Is normative in the sense that should contribute some way to the maintenance of the system.
Yes.
Okay. Then I see that your point of disagreement is what I have included as adaptive as in a sensory model, probably, because the other questions is basically the idea of autopoietic and the idea of some individuation. And this seems to be.
So my point is that you can build such a self-maintaining system by assuming that first you have the equivalent of what I call condition action rules, which can be implemented as chemical reactions. The input is a condition, the output is the action. And you can show mathematically that under quite a wide range of circumstances, you can have these reactions or these condition action rules that form this closed autopoietic self-maintaining whole. So you start actually with the condition action rules and you end up with a self-maintaining system. And then you no longer need to argue, yes, but once you have a self-maintaining system, it also needs to have the sensory motor interface, because the sensory motor interface, in a sense, is what started it out. So the condition action rules are, in fact, the building blocks of your system, and most of them now have become internalized, but they still connect to the environment, so they still interaction with the environment, because there must be thermodynamically things going in and things going out.
We have a question or a comment from Dirk. Is it okay? Next question. Dirk van Helder.
Yes, thank you. Professor, you explained on minimal agency. To truly speak about the minimal agency, it has to move, but it has also to evaluate. For instance, finding food, and this is an area, food, non-food. I'm interested in minimal agencies which show some kind of self-consciousness. So they are probably more complex than minimal agencies. Although, if you say, and like you said, it has to evaluate good from bad, you could say that there's some origin of self-consciousness already built in. Or what is your opinion on that? Is a self-conscious minimal agent, is that far away from what you described or not?
Yes, I think it's as far away. A clarification on, I'm not saying that necessarily a minimal form of agency requires movement. It could be the case of secretion of chemicals. One point that I wanted to mention, I have forgotten in my talk, is that some minimal cases are on the limit of the way we address immunological domain, rather than the way we address the adaptive domain, which is the origin of what becomes later the nervous system, etc. But letting this aside, which is a different discussion, self-consciousness implies, well, it's a very, very hard to analyze question. There are a lot of discussions. Recently, there is a very interesting book written by Eva Jablonka and Simon Ginsburg, but in my view, they address the question in a very sensible way. Usually, authors consider that there is needed a form of developed nervous system, but where is exactly the limit of complexity of this nervous system, which implies a form of interaction between physiological, emotional, and sensory motor processes, is a question that really requires another talk.
Thank you.
Sorry.
Anyone else?
So
I have a question, but I don't know if somebody else wants first.
Yeah, there was one question in the room, and then you did, Eric. Okay.
Okay.
Okay,
Please.
thanks, Alvaro. It's a very small comment. I'm also trying to think about agency recently, and one thing that I never really can grapple with is, for example, in this book it's an old book right now by Kaufman on investigation, which was kind of like the first book that got me on this route. And he seems to be very fascinated by autocatalysis, and this, what makes me think of this is your final reference to population of protocells. So do you think that population of protocells, or because, for example, Kaufman defines autocatalytic sets as already autonomous agents, and for me, I was always a little bit more skeptical, especially given, because I'm not sure that they really realize the condition for biological autonomy. So I was wondering whether you think that you need a population of protocell is already definable as a minimal agent, or you need more condition, or you need, for example, sensory motor contingencies, you need adaptivity. So maybe you can elaborate a little bit on that.
As far as I know, Kaufman has a very long work, and he has evolved in his proposals. Autocatalytic sets were one of the former works by Kaufman before investigations was written. As far as I remember, when he has worked in the idea of autocatalytic sets, he has not developed so explicitly the idea of autonomy as he has done in investigation, where he enters all the thermodynamic framework. In his work investigation, 2000, although the draft was written 4 years before, he basically says constraints are necessary to produce work, and work are necessary to produce constraints. And this, he describes this idea of autonomy or autonomous agent, but this is very abstract in the sense of, look, the same as we see a human-made machine, like say a watch or a steam machine, as a set of organized constraints that harness a flow of energy, see, steam, in order to produce work which is functional, useful, release constraint of energy, ordered constraint of energy to produce something purpose with a goal. He wants to naturalize this idea of work, which is implicit in the thermodynamics of machines. And he says, but in human-made machines, we human beings produce purposefully the constraints, the cylinder, the valves, the tubes, etc., etc. Now, what happens in a cell? In a cell, there are constraints that are, for example, the membrane, the enzymes, constrains the reaction, the chemical reaction, constrains the flows of the energy, and the endergonic, exergonic reactions are coupled together. And finally, there is provision of energy, which is chemical energy, and there is a set of constraints. These sets of constraints are always decaying and always rebuilt. How? By the work performed by the mechanical devices in the cell. And how these devices, these machines, are produced? By constraining the flows of energy. So the cell is a kind of factory that has many constraints that produce work. And this work is useful because produce the constraints that produce the work. This is the explanation of Kaufman's explanation of autonomous agency. The problem that I see on that is that a description of what I have called the constitutive organization, because if we take the case of a cell, the cell is, of course, can be seen from inside. And of course, this description describes how the cell is a precarious, far from equilibrium, self-maintaining, self-producing organization. Right. But the cell can do things also in the environment, or can do things inside when the environment changes. The environment changes and the cell can modify itself, or the environment changes, but the cell can move or can eject a poison or do things modifying the environment. Now, I think that the idea of agency is more consistent with the usual way it is in the literature, with this second sense. Although I admit that there is many other uses, but if I want to be more close to the way it's more commonly used of agency, I think is in the sense of imposing constraints, functional constraints in the environment, and these constraints should be normative. Normative ultimately for the agent or for something which is related with the agent. For example, in a biological system, an agent can do things for other agent, not directly for him. For example, an ant, then probably things become much more complicated, because ultimately this ant depends on what the whole collective society does. But things become much more complex. And there are many other examples of nested agents, like plants, etc. Sorry.
Can I just pick up on that? What you are explaining, I think, may be similar to what in our project we make the difference between self-maintenance and what we call resilience.
Sorry?
Resilience.
Resilience.
So resilience is the idea, if the environment perturbs you, you should be able to neutralize that perturbation. Well, self-maintenance is, as you say, it's the canalizing of this flow, this thermodynamical flow, so as to extract work. So as long as nothing changes, that's fine.
Yeah.
But the environment will impose certain what I call challenges on the agent, and then the agent will need to react to the challenge by the environment. And that is what we call resilience, in the sense that self-maintenance means surviving in ideal circumstances. Resilience means surviving also when the environment influences you, when the environment changes, and you have to intervene in the environment in order to survive.
Well, what about when you imagine that there are two different situations? In one case, the environment provides you with what you need because the environment is very stable. A limit case is an endosymbiont inside a cell. The cell provides him with all what is needed, or even some plants. Or there are probably very few cases in which in the biological world, but there are cases. Now, in other cases, and probably in the majority of cases, the environment, not only the environment changes, but also the needs of the system changes, and then it has to do things in order to, because Well, in fact, because the environment changes, because the environment does not provide him what he needs all the time. And then the system should either modify himself or necessarily do things, which is not a necessary condition for every organism. I have mentioned that there are some cases in which there is no need to do that. But in the majority of cases, there is need, and you call that resilience.
Yeah.
Okay, it's clear for me. Yeah.
We have two people who wanted to speak first, Diderik and then Vishal. Okay, so Diderik, if you...
First of all, thank you for your very interesting talk. Makes me reflect about many things. About my question, a little bit weird perhaps, but since you talk about minimal agents, how would you say that you think of living systems and what is still living and what is not living anymore, I suppose. But what if you think of a piece of matter that we classify as not living, just that matter? What is missing there to give it the name of an agent?
Well, many things.
A stable piece of matter, huh?
A stable piece of matter, many things. Many things. A stable piece of matter will be there for an indefinite period of time without changing his identity. And therefore, hardly, well, in fact, you don't claim that this is, so you ask, what is lacking? What should be added? First, I think it's important to stress a point, which is that we need an organization, but this organization is in fact a structure of pieces. But this structure of pieces, for example, a man-made machine could be inert, could be a conservative structure. Hardly a conservative structure could become an autonomous agent because it's hard to see how the things that eventually this organization of structure, conservative organization of structure, is affected. His identity is affected by what he's doing. So suppose we build a robot, and the robot, say a robot in Mars or a robot in a factory, is doing a lot of things, but then the robot stops and the structure of the robot is there. Nothing changes in the structure of the robot. So the robot is not affected by what he's doing. And therefore, if he's not affected what he's doing, we cannot attribute these actions a failure or a norm, except for those that have built the systems, the machine, of course. But then the agent is not the robot. What is the point that I have mentioned at the beginning? So what is necessary for building an artificial agent? That the system is affected by what it's doing. And the only way I see that a system is affected, become affected by what it's doing, is when the system is far from equilibrium, has a structure which is far from equilibrium, which is precarious. Because in that sense, it has always to exchange matter and energy with the environment so as to become the same, so as to maintain its identity. And that's the only way I see this, what we see in living entities, but also in case we are able to fabricate models or in fact robots or devices that become artificial agents.
would you say then that there needs to be an exchange, a kind of exchange of energy, continuous exchange, or at least not zero exchange of energy?
Not only energy, matter, because the system should be affected by what he's doing. In the case of, suppose, only energy, the structure of constraints, which are material structures, if these material structures are there without the supply of energy, then the problem is what I have already mentioned. So the material structure should be precarious, should be affected what this material structure is doing as a source, as a cause.
And do you make any connection with entropy?
Yeah.
The systematic keeping low of entropy, would that be?
Yeah, exactly. The system should be a far from equilibrium system. Should be maintained by their own actions in far from equilibrium conditions.
Okay, thank you. But for example, just to have an idea of where you see minimal, this whole reflection about Gaia, the Earth and Sun system, would that be meaningful to reflect about that, or would you declassify it immediately as an agent?
Good question. Good question. This is related with the question of individuality. What is the system and what is the environment in the case of Gaia? If we are capable to define Gaia in a different way of the environment of Gaia, which is not clear for me, but I'm not reject the possibility, then maybe Gaia could be a global agent.
Could classify as a minimal agent, you mean?
Now, a minimal agent, no, because we probably can distinguish pieces of Gaia, let's say organisms, that are systems with a much short lifespan, temporal lifespan, with a much short space domain, spatial domain, that fulfill the definition of an agent, and that's probably can be defined as simpler than the whole Gaia.
Okay, I see. And I also have questions. What are your thoughts about if you think of collections of people, societies, nations? Or they classify as agents?
Oh, here we deal with a very complicated question. The case of collective agents. When, for example, when we have a colony, we can probably say that in some cases, very clearly, we can say that the colony as a whole is an agent. But at the same time, I can ask, but each of the microbes, for example, in the colony, say a biofilm, each of the bacterium that in many cases can also have a free living condition, in other cases not, is not also an agent. And then if I take the case of each cell of myself, of my body, if a cell of my body an agent, or the agent is myself as a whole, is a society of persons an agent, or are the persons that belongs to this society agents? For example, imagine that you have a company, and the company the company is responsible for a very strong accident. There are people that are died. So the responsibility, the penalties or the for being in a trial, for example, is on persons, individual person, or is the whole society, or when you consider that a country is has invaded another country, is the country as a whole, or are specific persons the agents that this raises a lot of problems because these nested relations. In fact, I have more carefully studied the cases of some organisms in which there are different possibilities of nested agency. In some cases, the most complex form of the interactions displayed belongs to the parts, in which case I would say that the whole system is a very weak agent. In other cases, for example, animals, very integrated animals with nervous systems, the whole is capable to achieve properties and complexities that are completely lacking in the agency of the parts. So these are emergent properties like, I don't know, vision or consciousness or many complex forms of agency that, for example, vertebrates are capable, and that you cannot attribute to any cell of the body of these animals. Instead, if you consider a ball box, which is a kind of multicellular system, you see that the movement of the ball box, in which you have several thousand of cells that move the cilia together synchronously towards the light, is not something that is especially more complex than what individual cells can do. Of course, the whole is more contributes to the maintenance of the whole multicellular entity. But as the case of plants also is very complicated. The more modular is the global system, the less strong is the properties of the whole, or the emergent or the new qualitative properties, agential properties of the whole. And the more integrated is the system, the more interesting and emergent properties you can see attributed to the whole. But this is a very complicated issue, really. And you have many frontier or borderline cases.
Yeah, the structures are nested. But thank you very much for your answer. It's a lot to reflect about still.
Let's continue with the discussions. Vishal, you wanted to speak, yes?
Yes. Thank you, Professor, for such an insightful talk. My question revolves around the ability of an agent to repeat its action over a period of time. So, is there any role of memory in this, or is it purely homeostasis?
Sorry, I have not very well understood.
Could you please repeat? We are not hearing you very clearly.
Okay. I am curious to know about. Can you hear me?
Yeah.
All right. Is there a role of memory in
Memory.
Memory in agent's ability to repeat its action over a period of time, or is it purely homeostasis?
I see. I see. If I have well understood your question, you are wondering about the role of memory for explaining action, or whether it's just a question of homeostasis. I have rightly understood?
That's
Well, homeostasis is a sine qua non condition. Homeostasis is a way of defining that a system that is an autopoietic or self-maintaining system has an identity and maintains some essential values. And then when the system is approaching the limits of these essential values, the system reacts or try to react in order to maintain this homeostasis. For example, we try to maintain a temperature in our body of 36 degrees, and if there is external heat, we make things, or elsewhere we try to make exercise, etc., in order to keep the homeostasis, the chemical temperature, etc. of the homeostasis. In some sense, is a kind of dynamic identity of a system. Now, then homeostasis, in the sense of this far from equilibrium identity of the system, is what I have said is what defines the necessity to keep the homeostasis, is what, when the environment changes, is what is the key for triggering some actions in order to maintain this homeostasis. Now, the question of memory. In many cases, even very primitive systems have properties like what is called habituation. This is a kind of very primitive memory, in the sense that things that happens once and again, the system is able to not to repeat the same type of functional actions that have been done at the beginning, when this was a new event. And if the system has learned, and learning is related with memory, then the system may avoid trial and error in order to find, or some process of trial and error in order to find a good solution, or a best solution, or an optimal solution to keep the homeostasis. I don't know whether this is a satisfactory answer to your question.
The reason why I asked you this question was, I was wondering what makes agents want to duplicate themselves or their own systems. Why did the first cell decide to divide itself? So why did the first cell decide to divide and multiply?
Why do that?
Why did it?
Yeah. First of all, when you study the minimal protocells in natural conditions, or in a laboratory where minimal prebiotic conditions are tried to be reproduced, you see that what you find is not that protocells achieve a steady state. The normal thing is that they grow and they divide, they fuse, so they are dynamical. And therefore, although Varela said that it's more fundamental, the idea of self-maintaining, than the idea of self-reproduction, logically speaking, but in fact, empirically, to find systems that achieve steady state self-maintenance is very difficult. And in fact, what you find is that there are a messy of systems that grow, that shrink, etc. And probably some of them find a solution, which is that they grow, and then when they achieve a critical size, they divide, and probably in many occasions they produce two different entities. But in a given moment, a form of organization was found in which the growth produce similar entities, at least statistically, and so probably this the way in which a system what gets stabilized was by self-reproduction, not but merely self-maintenance. So I'm trying to answer why. Why? Because otherwise these systems would have disappeared. And in fact, there existed many other types of systems. In face of some teeny amount of them that found this form of organization in which they self-reproduce with some kind of reliability, and they persist. All the other forms of organization, sooner than later, have disappeared. Because imagine that there is very dynamical conditions and very unstable forms of organization. The whole, some form of stability, and because you find systems, and these systems that you find are those that have persisted. The others that have not persisted have disappeared. You will not find them, and this is the answer.
So the answer to the why would be because they are lucky, yes?
Because they are lucky, and because lucky, the lucky fact is that they have persisted.
Vishal, yes? You are muted now, we cannot hear you. Unmute. Vishal, you are muted. Can you hear me?
Yeah, I can hear you, sorry. Yeah, so my question is a follow-up to Doug Helder's question on desire, consciousness, and agency. Do you have any views on agency, agent, and desire?
Yes, agent and desire. Desire can be understood in a conscious way or in an unconscious way. Desire, it comes to my mind Spinoza, the philosopher Spinoza, who said that things have a conatus. He used the Latin word conatus. Conatus means that things tend to persist. Then life tend to persist. Why tend to persist? Because it's a kind of closed organization that tries to maintain itself and has a lot of mechanisms in order to maintain itself. Of course, it has many of factors that weaken that and finally make that destruction for thermodynamical reasons happens. But since life is an organization that not only has an individual dimension, but also a collective dimension through reproduction, it tends to persist. It tends to persist individually, and it tends to persist collectively, and it tends to persist even synchronically through cooperation. It tends to persist. It tends to fight against environmental challenges and difficulties and dangers. Desire. You can consider desire, a form of desire, this way. But also you can ask another form of desire in which the desire is a kind of thing that is felt, that is experienced. But then your question is related with the former. How can I see the origin of consciousness? And this requires another talk. Really, it's a very complicated issue.
Thank you, Professor. Thank you.
Anyone else? Questions, comments? Back to Francis.
Yeah, on one of your slides, you said that the action should be anticipating, should be a perspective, should be reacting before things go bad. So in how far do you think that actions should have some kind of a prediction capability? Is there some kind of a feed forward in there, or is it just feedback that after something is going wrong, the system reacts, or is it anticipating things going wrong?
You are raising a very, very important and interesting question. You can have two different possibilities. Either you are considering a system without what I have called dynamical decoupling, in which you have mechanisms of feedback. These mechanisms of feedback are processes dynamically coupled in which the system, so to speak, reacts and maintains a kind of equilibrium. The use of the term anticipation that I use when characterizing regulation is a different one, in which when some processes are blind to the constitutive organization. For example, a system can have a mechanism that the mechanism, because it's genetically acquired, knows that in front of such a particular situation has to trigger some reactions. Although this is not detected as by the constitutive organization as something which jeopardizes the system. So it's something that is completely decoupled to the basic organization. How can I explain that? Well, because you can explain that in a population of protocells in which there is a mechanism of selection at somatic time, but also a mechanism of selection at a phylogenetic time. And then, by a kind of process of natural selection, some of these protocells acquired by chance, because those that acquired by chance this mechanism survive for longer than those that lacked it, then they acquire a mechanism, a regulatory mechanism, a regulatory norm, a norm that tells them to do something in advance because the population has learned that. For example, a population of bacteria can learn in a given set of generation that something should be reacted in a given way, and his immune system, etc., can change his constitutive organization, can change such a way to avoid blah, blah, blah. This is a norm which is completely blind to the actual constitutive organization, but can be explained through a phylogenetic process.
So just to follow up on that, so evolution is in this way of putting the issue, evolution is a condition for anticipatory behavior.
For regulation, for the appearance of regulation, I would say yes. Then later, when much more complicated multicellular organisms appear, there could be also forms of regulation that have appeared at the somatic time, like immune and many others within the nervous system, because the time scales of the organism and the organization of the organism, but the origin, the minimal form of regulation, the only way that I can explain its appearance is through evolution.
Can I just follow up very briefly? I was reading recently, I think it's the second book by Robin Rosen on anticipatory systems. I was wondering, while you were talking about anticipation, and I'm glad that Francis asked the question, how do you relate this particular, if you have a relation between this particular way of thinking about anticipation as mediated through evolution and phylogenetic learning to the way Rosen thinks about anticipation?
Frankly speaking, I don't remember. I have read this book by Rosen so many years ago that I really don't remember how he explains, how he uses the word anticipation. In fact, the word anticipation can be used, and in the literature is used in many different senses.
I'm trying to understand as well, that's why I asked the question.
And in fact, for example, Mark Picard used the word anticipation just in a very basic sense of dynamical presupposition. If you have a dynamical system that is closed in the sense that, for example, a basic autopoietic system is a protocell without regulation, in which you have a set of dynamical processes, in which is a loop. He says each process, in some sense, anticipates. He used the word dynamically presuppose the other, because the logic of the system is the whole loop. It's also that could be described as a form of anticipation. But I have used the word anticipation in a different sense. So, in fact, I have no objections to using words in different sense, provided that people define clearly how uses the words. In order to avoid the mistakes, and so I'm trying to do that. So I have used the word, but I have also said I use the word in this sense.
My suspicion is that people make more out of anticipation than it really is. And anticipation is kind of implicitly the result of evolution, as you say, because if you only start correcting a problem when it's too late, you die. So if you learn to correct problems before you die, then you are working well, and that means that you are anticipating. But then people speak about anticipatory systems, like especially Rosen, as if it's something very special, as if it's something it requires some kind of a higher cognition. No, I think anticipation is implicit, as we say, even in the loop. The one part of the loop is in sense anticipating that it will be completed by another part because it needs that other part to keep itself going.
Maybe a way to avoid this confusion is implicit anticipation and explicit anticipation. A regulatory system, I would say, is an explicit mechanism of anticipation, because explicit in the sense that there is a mechanism, a material mechanism that has a kind of materially embodied norm. There, the norm is anticipatory, in the sense that why is this norm?
If the norm is explicitly represented inside the system somehow, but even that is not necessary.
Well, there are other forms in which you can use when you have a plan. Then you have a representation, then a mental representation, not necessarily conscious, but mental representation that permits you to anticipate your movement in order to catch, for example, a ball, so moving before the ball, the trajectory
Although apparently there is a very simple heuristic to catch a ball, it has nothing to do with the representation. Apparently the heuristic is something that you should move in such a way that the angle of the ball coming towards you remains invariant.
Or this way, or this way, or this way, not necessarily represented. But another question is that even you can represent a situation which is not there, which is offline, etc. Okay, this is also a very
but in
conflictive.
hypermodal cognition, we have an explicit representation of a future state. But I suspect that 99% of all regulatory processes don't have any representation of the
of course. No, of course.
We are almost out of time already, so I see also Vishal wants to say something more. Vishal, or just yes. Yeah. So this will be the last question, and we'll be closing today. Okay. Yeah, Vishal.
Thank you, Professor. My question revolves around agent X, agent Y, agent Z deciding to work together in a symbiotic relationship, and therefore with the development of a new kind of intelligence when they have to work together. Do you have views on evolution of intelligence with evolution of agency complexity? And do you have any views on what is intelligence singularity in complexity of agency?
I have some opinions, but frankly speaking, this is very far from minimal agency. Yeah, probably human society is a very good example and also complex and challenging example of collective intelligence, collective agency also. But can we really understand, we as individual agents or individual intelligent agents, what we are at the same time bringing forth as a collective intelligent entity? I have some doubts, to say the least. No, I will keep to the kind of things that I, humbly speaking, in my humble opinion, I control a little bit more. No, just I cannot tell.
Okay, it's a wonderful.
I cannot tell you.
It's a wonderful closure.
Wonderful question. Very difficult answer.
Okay, so we pause on this and we close with the doubts and this suspension. We'll stay with this. So thank you so much for your talk and all the discussions, and thank you all the participants as well. We're closing today. In a week from now, we have a next seminar about some application of our thinking about goal directedness and self-organization and also agency in the domain of social processes and policy development and distributed governance. So this will be a week from now, the talk given by John Banzel and Johan Beckers, the same time, same space, physically and the same link. So see you all there. And
let me say again that I am very pleased to be invited, and the discussion has been really interesting and fascinating in some points. Thank you.
Thank you.
Thank you.
Closing the Zoom room. Mhm.